Continuing on with the basics of hypothesis, the first thing that we want to discuss before we actually try an example is how we word decisions. So in my classes, what I request students to do is to make a decision and then to write a formal conclusion based upon that decision. And I differentiate between the two of them. So let's first of all talk about decisions. So we have two choices. We can fail to reject the null hypothesis, or we reject the null and accept the alternative. Now, these are two things that have to be said. When you fail to reject, that's all you say. But when you reject, then you also say that you accept. And that's how I want decisions stated. Now, in terms of writing a conclusion is what we would tell someone else as a formal statement of what we decided. And you have to make a decision before you can write a conclusion. And although the decision is in the conclusion, it's not worded in the same exact way, or should not be worded in the same exact way. So in my classes, when we write a conclusion, I look for three main parts in order to have a correctly stated conclusion. The first thing I look for is confidence or significance level. Then I look for either the wording that there is enough evidence, there's sufficient evidence, whatever you want to word as far as that goes, but it must say something about having enough evidence or that there is not enough evidence, and then to support, and then you write out the original claim. The original claim in as close of wording as possible is what you should be writing there. Now I, in addition, will many times write in some numeric value, even if that was not a part of the original claim, just to satisfy those people that are numbers people versus just pure words, looking for pure words. All right, so now let's go ahead and let's take a look at the example here on page 3 and answering the questions. So what I'm going to do is I'm going to read it, and I would encourage you to try this example on your very own. Shut off the computer or shut down the YouTube video and try it on your own, and then come back and look at the answers and see how well you did. So a corporation maintains a large fleet of company cars for its salespeople. To check the average number of miles driven per month per car, a random sample of 40 cars is examined. The mean x bar is equal to 2,752 miles and a standard deviation of s 350 miles. Records for the previous year indicate that the average number of miles driven per car per month was 2,600. For an alpha of 0.05, is there a difference between this year's average miles and last year's? Answer the following. Express the claim that there is no difference in symbols. So having no difference in symbols, what we're going to be looking for is that our claim says that there is not a difference, does not equal to. And then that will go right straight into IDing the null and the alternative hypothesis. We're testing the average number, right? So right here it says average, and that means that we're testing mu, the population parameter. So that's going to go both into the null and the alternative hypothesis. And now what we have to do is we have to decide what we're holding it up against. And it was last year's records for 2,600. So the 2,600 miles goes both into the null, which is the assumed population, and that's the breakpoint, so it also goes into the alternative. Now our claim is not equal, so the null is equality. Now it should be noted that truly the null and the alternative hypotheses are always complements of one another. So not equals complement is equal. But many books, many professors these days are just going for the null hypothesis always containing equality because that's the break point. And as we know with a continuous distribution, equality is not a possibility. There's no area under a particular point in the curve. So it doesn't make sense to look for equality for it to say rejection, and that's why it belongs in the null hypothesis. And so many books and professors will just stress that equality is what goes in the null hypothesis. However, it is truly the complement of what your claim is, what your alternative hypothesis is. And remember, the alternative can never contain equality. The null hypothesis must always contain equality. So with that said, now we'll go on and we're going to ID this as a left tail, right tail, or a two-tail test. The way that we ID being left tail or right tail is based upon the inequality in the alternative hypothesis, our claim. This says not equal, so not equal could be above or below, and that's going to make this a two-tail test. And so we have the two tails, and that's going to form our rejection regions or our critical regions. And what that does is it tells us what area that we're going to be using in these tails in order to find our critical value. So because we have a significance level of alpha, we have to divide that alpha by 2, just like you would for a confidence interval, because it is two-tail. But that is not going to always be the case. The left tail and the right tail tests, those, all the alpha goes into one or the other. And if we have a 0.05, that means alpha over 2 is 0.025. And so we'll look up critical values based upon that 0.025 being in either one of these two tails. And so that's why knowing whether this is a two-tail or a one-tail test is important to a traditional method test. Now in each of the types of the tests that we run, it's important to know. It just may change as to why it's important. Now the next thing that we want to do is we want to write the type 1 error. So remember that that a type 1 error is rejecting the null and accepting the alternative when the null is actually the correct decision. So here, what we're going to do is we're going to say that the mileage is different from 2,600 miles when it is actually the same as in previous years, the 2,600 miles. So the type 1 error is we have claimed that the mileage, and I'm just going to use symbols because it's quicker, is not equal to 2,600 when it is 2,600. And that's what a type 1 error is. So a type 1 error is rejecting the null and accepting the alternative when the null is actually true. So 2,600 was actually the case, but we've said no, it's not the case. Now we're going to do a type 2 error. Now type 2 error, remember, is failing to reject the null when the null is actually false. So in this one we've said the mileage is 2,600 when it is really not equal to 2,600. It's really different from 2,600. Now again, with restrictions on time, I don't want to write that all out perfectly, but obviously what I would say is that the type 2 error is saying that the mileage is 2,600 miles as it was in the previous years, when it is really different from the previous year's mileage of 2,600. Now our decision here is saying that we have decided that we're going to reject the null and we're going to accept the alternative. So the decision is going to be at the 5% significance level, there is sufficient evidence, or there is enough evidence, to support the claim that the mileage is different from previous year's mileage, a mileage of 2,600. So I'm going to go ahead and write that out because I want you to see it exactly like I want it written. All right, so here it is written out. At the 5% significance level, there is enough evidence to support the claim that the mileage driven per month per car is different from 2,600 of previous years. So the next one asks us to assume that we fail to reject the null hypothesis. And what I would like to point out is that this can be written exactly the same way. There's only one single little difference, and that is that we would interject into here that there's not enough evidence. But that is the only thing in this entire thing that changes when we change that decision. Now, what I do want to show you is on the next page, I've written out the same conclusion, but I've written it in just a slightly different form because there are a couple of little nuances that can change. It doesn't change the overall feel, it just kind of changes some of the wording. So let me point a few of those out. So the same conclusion could be written in this way. At the 95% confidence level, so confidence level versus significance level, that's one change that alters nothing. And then there is not enough evidence to support the claim. And then I've reworded the claim in just a slightly different way, holding truer to the original statement in the problem, the claim that the average mileage per car per month is different from previous year's mileage. And then in parentheses here, I wrote the 2,600 miles instead of putting it in the bulk of the claim because that's staying truer to the original statement. And again, notice the only difference between rejecting the null and accepting the alternative and failing to reject is that word not. That is the only difference. So hopefully you tried that on your own and you were successful. However, this was a new thing to do, so it very well may not have been. Now I want you to try to do these two examples definitely on your own this time around. And I want you to try to do all three parts, and then I will come back and I will write these out for you so that you can see whether you did them correctly or not. And then we will be off and running on our test statistics. So go ahead and pause and then come back and you can review the answers to the next two examples on page 4 of the notes. Okay, so hopefully you have stopped the video and you tried this first example on page 4 all by yourself. And when you read it, you understand that we're looking for averages, right? The average. And so we're looking at Muse again. And the past years are 380 pounds. So see how this goes in both the null and the alternative. And he thinks that his steers weigh more this year than in the past. So the claim is greater than, and the alternative should technically contain less than or equal to, although again you could just put equality here and I will not gripe about that. Now because the alternative hypothesis is a greater than, that creates this one-tailed upper tail test or a right tail test. So that is where our all of our significance level goes. Our alpha goes in this upper tail, and that will help us find the critical value for what we call a traditional test. Now the type 1 error would be that we've said that the steers weigh more than in the past when they actually don't weigh more. The type 2 error would have been that we have said that the steers don't weigh more than the 380 pounds when they actually do weigh more than 380 pounds. If we're going to reject the null and accept the alternative, we could state this as, at the 99% confidence level, there is enough evidence to support the claim that the steers weigh more than 380 pounds, and I put in parentheses of past years. Now the last one, decision to fail to reject the null. This is at the 1% significance level. There is not enough evidence to support the claim that the average weight of steers is higher than the 380 pounds of previous years. And I am out of time, so I will finish the second example in the next video.